Hello and welcome to the introduction to the chi-square. Up here I have something that might look very familiar to you, and it's called a contingency table. So if you remember all the way back to Stat 1, it may have been a while for you, you usually start with, hey, what are variables? What are the different types of variables? And then how can I describe these variables? And you go through categorical and then quantitative, and then usually if you took Stat 1 at Northwood, you go next to what's called Chapter 4, which is linear regression, which is all about, hey, how can I relate two quantitative variables? And then you stop. You're done, sort of. Well, actually, not at all. Then you get into doing probability and inference, and that lasts like 5, 6 chapters. And you sort of let go of the idea of how do I interact with two variables. But hidden inside of probability is what are called contingency tables. And contingency tables have some probability things that you can calculate with them. Ooh, sorry, I just accidentally zoomed in. Um, and I'm going to talk to you a little bit about the three types of probability. So as you look here, I really have two categorical variables, sex and prize, and the different categories those categorical variables can take on, like man and women, MP3, camera, and bike. And clearly this is old information because, it's using MP3, not MP4. And as you look at this, what I want you to be thinking is I'm exploring the relationship between two categorical variables. That's what this is about. And that's exactly what the chi-squared test is going to be able to tell us. So you might think to yourself, well, don't I already know how to investigate these? And there are some that you should already know. So I'm going to talk to you a little bit about the three big types of probability and how they relate to the chi-squared. So let's talk about the three types. Three types of probability. Woohoo! Probabilities. And this is covered in Stat 1, so if this looks familiar to you, sorry, feel free to stop watching. The first one I want to talk to you about is what's called a marginal. And these are so named not because they relate to a marginal cost or anything like that, but because they relate to the margins of a distribution. So if you look at this table, sorry, I just accidentally tapped it. There's all these values that appear along the edges. These are called margins, just like on a piece of paper, how the edges are called the margins. And these are all the total values. So the marginal is really all about like looking at one variable and asking what it looks like, because marginals are just going to use the margins to do their calculations. So say you want to know the probability that the person you were looking at happened to be a man. Aha. So you look at this and you're like, oh, how many people are male in this or men? And then you're 227 out of 478, which is about 0.474. Oh, that 4 didn't come up right. 895. I should stop at some point. Okay. Anyway, so that's what a marginal looks like because it's only using margin values. So that 227 came from a margin, that total came from the margin, there you go. Okay, so that's what a marginal looks like. And you notice a marginal ignores the fact that the other variable exists completely. The other categorical variable isn't used at all. So if you wanted to join those two categorical variables together, you would want to do a joint probability. And a joint probability looks something like, hey, I want to know man, and they selected a bike. Oh, I should probably tell you what this data is about. So this came from one of those prize wheel things where we had a wheel that had a bunch of prizes on it, like an MP3, a camera, and a bike, and then we would ask people which prize they would like to get before they rolled the wheel, and we recorded this information as well as their gender. So, sorry, sex, not gender. Anyway, so man and bike. Hey, how many people wanted a bike? Well, 60 out of the 478. And that's exactly what a joint does. It combines two variables and it's a and. So notice 60 comes from within the table. Come on. There we go. Not from a margin. And that's a very typical characteristic of a joint probability. All right. The last one I'm going to talk to you about, and this is the last big type, and that's a conditional. That's supposed to be a C. Hold on, we'll fix that. So conditionals are always about on the condition that I already know this happened or under these conditions. So suppose I want to find out, hey, what's the probability that a person is going to select a bike as their preference given that the person is a man? So I know they're a man and they picked bike. Okay. So you look over here at the table and you're like, oh, well, looking at only the men who picked a bike. Well, 60 people out of, well, I'm only looking at men, so out of 227. I'm hoping you notice that these numbers are all seemingly to be a little bit related. You know? Oh, I didn't do a decimal for that one before this. Oh well. And if you're looking at this and thinking, oh, well, pretty sure I know another formula for conditional, you do. You absolutely do. Here we go. So, the formula for conditional probability is the probability of A given B. So I know B, what's the probability that A happens? Is the probability of A and B given that B already happened. Hopefully that looks familiar to you. So if you had done this calculation, the bike given I know it's a man, using the formula, you would have done the probability of bike and men divided by the probability that the person you selected was a man. So you're really looking at, oh, I already know it's a man, so it's got to be bike and man, and I'm dividing out by man to account for the fact that I already know it's a man, so I don't need to know anything else. What would this be? I'm hoping you notice that this is just a join over a marginal. And that's really what all conditionals are, is they're a combination of a join with a margin, or a let's join together and then cut out the other one. Today's title should have also been Fun with Fractions. So there you go. So you look at this and you're like, oh, well, these are all interrelated. All probabilities appear to be. So how am I going to describe relationships? Well, that's what I've got down further. Hold on. What is this? It's a new table. It's the same table, but with different numbers. What happened? Okay, so these are the percentages. Sorry, I'm just changing colors. From the above table based on dividing out by the total. So I just took everything up above, divided by 478, and then typed actually the proportions. So as you look at this, what we want to ask yourself is there a relationship between gender and prize? So you might ask yourself, does a specific gender tend to select one prize more than the other? And is it a significant enough difference to mean gender impacts people's selections? And if you looked at just MP3, you might look at these and be like, oh, those are pretty close, so there's not an impact there. If you look at camera, you should be like, oh, well, women definitely seem to prefer the camera. And then you look at the bike and you're like, okay, so for the camera one, you might be like, oh, but that might not be enough of a difference to be significant, which is what we just spent like 4 chapters doing. Hey, is the difference significant enough to matter? But then you look at the difference in bike and you're like, whoa, 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 whoa. Clearly something's going on here. But again, is it enough to make a difference? And that's what Kai is going to do for you. It's going to tell you, hey, is the difference enough to be significant for categoricals? And that's what you have to look forward to this chapter. Enjoy!